We've been looking at voting theory and looking at how people vote. And we did an exercise last class period where we looked at different type of voting for our favorite candy. We looked at the popular vote. We then looked at having a representative where you guys were all in different size groups and you chose one representative and they came back without getting any information from you guys and then voted. And then we talked about, you know, what was fair with that or what wasn't fair. And then we had your representative of each group go back into the breakout room, discuss what you guys wanted as voters for your favorite candy. And we came back in and you guys voted again. We looked at then, you know, is it fair because of the different sizes of the groups and how could we weight it so that it would be more fair for that group. And so that kind of ties into looking at the electoral votes and how many electoral votes each state has depending on the size of their population. And so you're going to be today and maybe tomorrow preparing by looking at, so you want to choose California as one of your states, and then you're going to choose 2 other states. Hopefully you guys aren't choosing all of the same states so we can get more of a variety and disbursement of what we see. So what you're going to want to do is you're going to want to do some research. You're going to want to figure out the population of that state and figure out how many electoral college votes they should have versus off the population of the whole United States. And so come up with a number you think would be good and then go and do some research and find out what is their, how many electoral votes does that state actually have. And so because we're looking at this is actually is dealing with proportions, and we will deal with proportions later, I think, in this class if we do talk about game theory. And so let's talk about proportions and what is a proportion. And so a lot of times we look at things where we're comparing 2 things. And so for instance, if you're looking at a blueprint, 1 inch on the blueprint is going to represent, you know, how many feet maybe that wall is. And so you're relating 2 things together. And so for instance, we're going to be comparing, you know, the population of one state to the population of the United States, or in how many votes that one state should have versus the population. Okay, and so proportions are where you're looking at, you're setting to equivalent ratios equal to one another. So again, like I said, one example would be that blueprint. So let's say you have a blueprint and 1 inch again, let's say is equal to 7 feet. And you're looking at the blueprint reads 1 wall is 2.5 feet. I'm sorry, 2.5 inches. How many feet is that wall? So how many feet should you build that wall?
What does it say after where it says setting to equivalent? and the
Yeah.
little icons blocking it.
Oops, sorry. I wish I could get rid of those on there. So yeah, so it says a
A
setting
ratio.
two ratios equal to one another.
Okay, thank you.
Okay, so if we have a blueprint is 1 inch is 7 feet. So basically that's a ratio. And so when we write out this ratio, we know that 1 inch is equivalent to 7 feet. And so when we set our proportion, we know that we have 2.5 inches. And so we know that, and you need to be consistent. So if I put inches in my numerator here, I need to put inches in my numerator on the other side. So this is 2.5 inches. And we're trying to figure out how many feet. So this is our unknown, and this is what we're trying to find. So let x equal the number of feet of a 2.5 inch on the blueprint. And so we want these equivalent to one another. And so we're going to put an equal sign in here. Okay, so recall, and I don't know if you remember, but if you have two fractions equal to each other, we can use what is called the cross product. So if we have, let's say, a over b is equal to c over d, a fraction equal to a fraction. I'm just going to cut this. And then basically we can use the cross product. And the reason why we can do this is because if you have an equation, which we do, we can clear our fractions by multiplying by your LCD. And so our LCD of this fraction, that's your common denominator. And your common denominator, we don't know what the denominators are in this case, is BD. So if I'm just going to show you why. So our common denominator is BD. If I multiply both sides of my equation by BD, and I can do this because if I do something to one side of the equation, I can do it to the other. Then notice that here we have BD times A over B. The whole point of me doing that was so that my denominator could go away. And so notice that they both have a B in common, one in the numerator and one in the denominator that cancel out. And so here we would be left with, on this left-hand side, D times A. You can write it as DA or you can write it as AD. Doesn't matter. So on the other side of the equal side, when we multiplied also by B over D, or BD, notice that D's cancel with one another. They both have a D in common. And so we have, this is the same thing as C times B. Because that works, we can do what is called the cross product. So the whole reason behind the cross product is what we just did. So if you have A over B, so a fraction equal, a single fraction equal a single fraction. This does not work if you have more than one fraction on one side of the equation. But the cross product says what you can do is just multiply diagonally across this equal sign. And so we have A times D is equal to B times C. So if you want to, we can use this when we're solving for proportions. Okay, so looking at my ratio, we have 1 inch over 7 is equal to 2.5 over x. And so now we can use this cross product. We can go across. So we have 1 times x is equal to the 7 times 2.5. Okay, this is where we got to be careful. Multiplication, when you have multiplication and you have a mixed number, you have to rewrite this as a improper fraction. So some of this is kind of review in here. So if you have a mixed number, so let's say maybe capital A, B over C. Remember to rewrite this as an improper fraction. You take your denominator, which is C, multiply it to the whole number, which is A, and add it to the numerator. And put that all over the original. So if I do this for my 2.5, so 2 times 2 is 4, plus my numerator, which is 1 all over 2. So this is the same thing as 4 plus 1, which is 5 over 2. So we can rewrite this as the same thing as 7 times 5/2. So x is equal to, so recall multiplication with fractions, you don't need a common denominator and you just multiply your numerators together and your denominator. So 7 times 5 is 35 all over 2. So let's rewrite that as a mixed number because we had a mixed number to start with. So 2 goes into 35. You have to do long division, it's okay. 2 goes into 3 once. 2 goes into 15 7 times, which is 14. Remainder 1. So this is 17 is our whole number, your remainder over your denominator. And then make sure you're putting in what units we're talking about. So that 2.5 inches relates to a 17.5 foot wall. Okay, so I'm not sure where you guys are, how much you're remembering your rules of fractions and stuff. But let's look at another example. So I just want to pull some problems just so we can look at them. So let's say we had this number 1, C over N, I'm sorry, not C over N, C over 9 is equal to 4 over 17. And we want to solve for C. So again, we're just going to use our cross product because we have a fraction equal a fraction. So we can look at C times 17 or 17C is equal to 9 times 4. So let me just simplify each side of my equation down before I solve for C. So we have 17C is equal to 9 times 4, but 9 times 4 is 36. So let's get C by itself. We need to get rid of the 17. It's multiplication. So to undo multiplication, we're going to divide both sides. So let's divide both sides by 17. So C is equal to 36 over 17 Well, 17 times 2 is 34. So 17 goes into 36 2 times with 2 left over, so 2 17ths. Just write number 2 down. So 2 says you have y over 1 is equal to y plus 13 all over 4. Okay, fraction equal fraction, we can use our cross multiplication. Y times 4, 4 times y is 4y, is equal to this 1 times y plus 13. So we get 4y is equal to y plus 13. Okay, so you got an equation, you got a variable on each side. You have to look at what type of equation, it's linear. So that's where you want to get all the terms with a variable to one side of the equation. You can do this just because this is an equation. So we could subtract y on both sides. So we have 4y minus 1y is 3y is equal to 13. Get y by itself. You're going to divide both sides by 3. So we get y is equal to 13/3. Which is the same thing. 3 goes into 13 4 times. So this is 4 1/3. Okay, so jump into the next one, which was 1 all over n plus 27 is equal to 3 all over n minus 18. So just be careful here when you're distributing. So when I'm multiplying this 3 times n plus 7 and this 1 times n minus 18. So technically, because there's more than one term in the denominator, you should have parentheses around that. But we're multiplying by a 1, so it's really not doing anything in that case. And then if we multiply across here, we have 3 times this. We definitely need the parentheses around the n plus 27. Okay, so solving an equation. So this is n minus 18 is equal to, so we need to use our distributive property and distributed 3 to each term. So 3 times n is 3n plus 3 times 27, which is 81. So get variables to one side, constants to the other. So if we add 18 to both sides, and how about let's subtract 3n on both sides. So we have n minus 3n is negative 2n. 18's cancel, equals 81 plus 18. So that is 99. get n by itself, you have -2 times n, so undo multiplication with division.
You're right, we just had a break and went to breakfast, honey. Now we gotta work.
So we have n is equal to 99 divided by -2. And so a positive over a negative is negative. And 2 goes into 99. That goes in there for. Right. So that would give me 8. So this would give me a remainder of 1. That goes in there. 2 goes into 19. 9 times. So this is -49. Okay, so hopefully this is all coming back to you. So let's just do one more. So 3/8 is equal to 15 all over 7k minus 11. Okay, so cross multiply. So 3 all times 7k minus 11 is equal to 8 all times 15. Okay, so distribute our 3 times 7k, that's 21k. Minus 3 times 11, so minus 33, equals 8 times 15. So 8 times 5 is 40, carry my 4. 8 times 1 is 8 plus 4, so 120. Okay, can't simplify any further on the equation, so isolate the term with a variable. We're trying to get k by itself. So first thing you would do is get rid of the terms that don't have that variable on that one side. So add 33 to both sides. And so we get 21k is equal to 120 plus 33 is 153. Get k by itself. It's multiplication now. Divide by the coefficient in front, the number in front. So we get k is equal to 21 over 53. 153. So it's probably about 7. Let's try it. Yeah. So 21 goes into 153 7 times with a remainder of 6 all over our common denominator of 21. So I can't stop there because 6 and 21 have a factor in common. 6 and 21 both have a 3 in common. So 3 goes into 6. 3 goes into 6 twice. And 3 goes into 21 7 times. So now going back to what I wanted you guys to do with looking at electoral votes, how can we do that? Or how can we look at what we think the electoral votes are using proportions? How are we going to use that? So we want to look at California, just because we all live in California, I think. look at California and 2 other states of your choice. And figure out how many electoral votes those states should have. And then compare to the actual. Once you figure that out, then go back and look at what they actually have. So compare your results to the actual number of electoral votes. And so when you compare, did you get it right? Did you get it wrong? Why do you think you got it right? Or why did you think you got it wrong? Are you off by a lot? Are you off by maybe 1 or 2? So you want to look at that. So you're going to have that done for, and we'll come back and talk about your results. So I'm curious on what you guys get. We can discuss after I turn off the video a little bit of how you might go about doing this, if you have any ideas and sharing with others. But then I also want to give you time to talk to the other person, if there is another person that picked the same topic that you did for a possible topic to go over in class this semester. And so you're supposed to pick a topic by today, but if you didn't, that's okay. I showed you guys how to get in there and pick a topic. So go ahead and pick that topic, and then you want to do a quick research on what that topic would curtail, and sorry, trying to do too many things at once. What that topic curtails, and then be ready to give like a 1 or 2 minute blurb on that. So I'm going to just stop the recording there.